This morning we talked about a to the power 3 times a to the power 4, and we saw that a to the power 3 is simply a times a times a 3 times. So this is our a to the power 3. Then it is multiplied by a to the power 4. 2, 3, and 4. So we have our a to the power 4. If we were to evaluate this without loss of indices, we will have this, and we simply have to count the number of a's that appear 1, 2, 3, 4, 5, 6, 7. This gives us a final value of a to the power 7. So if we can do a few more examples, but it should be quite apparent, quite clear that this 7 over here exists because of the number of a's which came from a to the power 3 and a to the power 4. So this 7 over here is closely related to the 3 and the 4 over here. So we can, if you would like, you can try some examples yourself, but you'll be simplified to become, in this case, a to the power of m times a to the power n. This will be a times a times a times however many times. Okay, this will be our a to the power m, so m times of it, multiplied by a times blah blah blah, we do not know how many times. In this case, let's say there are n times. So if we were to evaluate everything, we get a multiplied by a multiplied by, and how many of these will we see? M plus n times. It will appear m plus n times. Okay, so this is our first law that we have learnt. So your task was to find out what a to the power of m divided by a to the power of n gives us. Okay, so again we try with concrete examples. Let's say we have a to the power of 8 divided by a to the power of 3. What does this actually mean? We've got a times a. We're going to be writing it 8 times so that it is very clear. 1, 2, 3, 4, 5, 6, 7, 8 of them. Now this is divided by a to the power 3. A times a. Okay, so we have 8 of them, and we have 3 of them here. And in mathematics, we like to replace the division with a fraction. So a times a divided by a times a times a. So 3 of them. So our primary school mathematics taught us that, hey, same factors, let's cancel them. How many times are we going to cancel? We're going to cancel 3 times, because in our denominator there are 3 of them. Where did this denominator come from? Over here, there are 3 of them. This is our denominator. We are dividing it by a to the power 3, so 3 of the a's get cancelled off. How many are left? A times a times a times a times a. There are a total of 5 of them. So now we try to see, where did this 5 come from? Oh, it appeared because the 8 a's, the a to the power of 8 had a numerator, divided by a to the power 3 in the denominator. 3 of them get cancelled out, we're left with 5 of them. So this 5 came from the 8 minus 3. You can try it out with other examples yourself, but you should be able to generalize our original question. This gives us a to the power of m minus n. Okay, this is our second law of indices. Okay, let's talk about the third law of indices. Let's say we have this a to the power of 2, and let this have a power of 3. Okay, so we see over here that if we are going to evaluate this, we need to evaluate a square first. Then whatever the answer gives us, we cube it. Okay, so this can be rewritten as a to the power 2, a power 2 times a to the power of 2. We can expand. Inside here we have a times a times a times a times a times a. Okay, because each of this will be our a square, and a square. So we see that there are a total of 6 of them. Is there a relationship between this 6 and whatever power we've seen in the original question? How did we get 6? We got 6 as the final power because there were 6 factors of a. Where did we get it from? We had 3 factors of a square. That's where we got the cube. And each factor of a square is actually made out of 2 factors of a. So we should be able to see that this 6 came from 2 multiplied by 3. So let's try another example. Let's say we have a to the power of 2, then to the power of 5. So this gives us a square, okay, multiplied by a square, multiplied by a square, a square, a square. So there are 5 of these a squares. I can choose to expand everything out, but it should be clear to you that we're going to be getting 10 of them. Alternatively, we can go back to our first law of indices, which tells us that a to the power of m times a to the power of n equals to a power m plus n. So here I have a power m times a power n. These two they are going to give me a power 4. With a third one, a power 6, a power 8, a power 10. I just keep adding 2 to the power. So we get a total of a to the power of 10. Instead of adding 2 plus 2 plus 2 plus 2 plus 2, I can simply take 2 times 5, which is 10. Okay, so the third law of indices shows us that a power m to the power of n must be equals to a power m n. Is there a difference between a power n? Is there a difference between a power m n versus a power n m? Is there a difference? So try it out yourself and convince yourself whether they are the same or not. At this point in time, I want you to go through go through example 1 first. Page 3, example 1. Look through it, then do try it 1, A and B. Likewise, go on to example 2, try it 2, question A and B. If you are confident enough, you can go straight to try it 3, A and B. Okay, after you have done, check your answers at the back. If you got it right, give yourself a tick. If you didn't get it right, find out where you went wrong and don't make the same mistake. Okay, by now you should have finished try it 1, 2 and 3 and you are familiar with the 3 laws of indices. So it's time to move on to the next law. Okay, before that, we need to explore, we need to try some questions. What happens when I have A times B to the power of 2? This gives us A times B multiplied by A times B. And we know that we can expand this to give us A times A times B times B, which is simply A square times B square. Okay, so usually we don't write a times b square like this, we simply write ab square. So we see there seems to be a relationship between the powers over here. Can we simply say that ab, the whole thing squared, equals to a square times b square? In this case we can. Can we generalize it? Instead of having 2 as the power, what happens when the power is m? Okay, so before we generalize, let's try one more example just to be sure. So let's say we have ab to the power of 5. Okay, this gives us ab, 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 ab. Expanding it out, we can get rid of all the brackets, replace them with multiplication. Then we see that we group all the same constants together. We have a to the power of 1, 2, 3, 4, 5. Okay, a to the power of 5 multiplied by b to the power of 1, 2, 3, 4, 5. Okay, hey, it looks like the powers, they're all going to be the same. So we generalize it to become ab power m equals to a power m and b power m. Okay, so m can be any value. This is the 4th law of indices. In your textbook they used n instead of m, but it's okay. Okay, and finally, the last law that we're going to learn in this topic. Okay, the last one looks something like this. Let's say we have a over b power 3. Again, if I were to expand this out, I get a over b, a over b, a over b. So fraction multiplied by fraction multiplied by fraction can be simplified to a big fraction with the numerators all multiplied together and the denominators multiplied together, giving us a to the power of 3 over b to the power of 3. Again, these are the same parts. So without doing another example, I'll show you the general form. Our 5th law of indices, a over b power n equals to a power n over b to the power of n. Okay, and we also say that there is another condition where b is not equals to 0. Do you know why? Figure it out yourself, you can discuss with your friends. So now we will go on to example 4. Read through it, make sure you understand, then you do. Try it for a and b. Okay? So this is the summary that we have. The 5 laws of indices. Take note for this and its equivalent forms. And over here, do we need to memorize? Actually, if you understand everything, you don't really need to memorize. Okay, but you must be very familiar with them. Okay, these are your homework questions. For question 1, take note that you have to leave your answers in index notation. If you have forgotten what that means, go and revise your lower sec work, or when you check your answers at the back, you should understand immediately what it means. So homework given today, due on Wednesday.